am so glad you were listening to directions and have your handout ready to go. All right, so what would I do first? Parent function. Every time I expect you to draw the parent function for me. How do I show that it's a parent function? Dash line. What does the absolute value look like? Okay. So, this was the one I skipped yesterday, I think, so you might have to go back in your notes a slide to get it. Everyone has a copy, right? How many exact points do I want?
3.
At least 3. So absolute value of 0, 0, 1, 1, negative 1, 1. You do 2, 2, negative 2, 2, especially when you have a graph in front of you. It's not, the grid's already there, not a big deal to do some more. That's my parent function. All right, what does the negative in front do? Flip it. It's like taking your ordered pairs and making the y negative. You could also just plug in points if you weren't sure. The absolute value of 1 is 1, but then the negative in front makes it negative 1. Put in a 2, you get negative 2. Put in negative 1, you get negative 1. Negative 2, negative 2. So it's flipping it over the x-axis. Flip or reflect. What is my parent function? X cubed. What's that one look like? 0 cubed is 0. 1 cubed is 1. If you need, you could do 2 cubed is 8. Negative 1 cubed is negative 1. Negative 2 cubed is negative 8. Okay, this time the negative is inside. It's attached to my x. So it's changing the signs on your x's. So it will flip it over the y-axis. Or if you think about the point, this is 2, 8, so it go to negative 2, 8. This is 1, 1, so it go to negative 1, 1. 0, 0 stays. 1, negative 1. Questions about those? So let's jump to this one. So this is kind of refreshing all the different transformations that we were talking about yesterday. So take a second and at least plot the parent function on all 4 of these. So do your parent functions, your dash lines, and then we can talk about the transformations together. This one is our absolute value. What would that plus 1 do to my graph? Up 1. I know it's outside the absolute value, so it changes y. Outside changes y and does what it says. So I take each of those points that I just plotted and shift them up 1. B, the square root, what's that one look like?
Attention staff, please check your email for a message from Mr. DeGrave. Staff, please check your email for a message from Mr. DeGrave. Thank you.
All right, so square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, so it looks like this. And what is our transformation this time? left one. Inside changes x and does the opposite of what we said. So would I actually go left? I'm going to go right. Okay, inside is opposite. So subtracting actually moves it in the positive direction. And when in doubt, you could always just plug in a point and see. You know, if you try to put in 0, you can't. You get an imaginary number. So I can't start until 1. All right, third one. What's our parent function? X squared. So the parabola, 0 squared is 0, 1, 1, 2, 4. This is inside. Inside changes x and does the opposite of what it says. So adding would actually move it in the negative direction, so it will go left 3. And our last one here. So the x cubed, what's that look like? Okay, transformation this time. It's on the outside because it's not being cubed, so it changes y, does what it says, so a negative will move it down. 4. How are we doing with these? Good. When in doubt, could you make a T-chart for them? Sure. It's just time consuming. But if you know the parent function, we are getting to the point that hopefully we've graphed them so many times, and as we continue to do so, those will get pretty quick for you to graph the parent function. And so then knowing the transformation just takes a couple steps. Now, all the problems we've done so far just have one transformation going on. Let's look at some problems that have more than one transformation and talk about applying both at once. This problem, I have a suggestion. The horizontal stretching and shrinking is tricky. If you can rewrite it as a vertical, it's a lot easier to think about. So if you look at that, what could you take out? 2. And can it come outside of the absolute value? The absolute value of 2 is 2, so I could take that out. Oops, maybe x minus 2. All right, so my transformations. What does the minus 2 on the inside do? What does the 2 on the outside? So I start with my absolute value, my v. At least 3 points, but you can do more. So, you don't have to write out points, but if it helps you, you can. Especially with the stretching and shrinking, I think sometimes that can be helpful. If I'm dealing with the stretch, it's outside, so it's going to change my y values. And outside does what it says. So all I'm saying is that stretch just multiplies those y values by 2. What else do we have to do? Move it right 2. Okay, so I take 0, 0. When I stretch it, it stays there, and then I'm moving it right 2. Okay, if I take my point 1, 1. When I stretch it, it goes to 1, 2. And then we move it right 2. Negative 1, 1. When I stretch it, it goes to negative 1, 2. And then right 2. Could you do more points if needed? Absolutely. We have 2, 2. Negative 2, 2. If you felt like you weren't sure, do some more points. Just take your y's times 2. So 2, 2 would move to 2, 4. And move it right 2. Okay, negative 2, 2 would go to negative 2, 4. Right 2. What we're getting is this skinnier absolute value that's been shifted over. Okay, the multiplying by 2 is just like stretching it out, so it got taller and skinnier, and we shifted to the right. Writing out order pairs is totally optional, but if you struggle with stretching and shrinking, I would suggest it on those. I want to do, we don't have to do all the problems I put on here. I put several, but we'll do at least one more and then kind of see where we're at, if we need some more practice or if we're feeling okay. This one has several transformations. What will the 1/2 in front do? Vertical compression or shrink. What will the +2 do? And the -3? So I'm starting with my square root graph. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Will my vertical compression change my x or my y? Outside is y, does what it says, so I'm multiplying those y's by 1/2. When you have multiple transformations, you have to make sure up and down comes last. So you want to stretch, shrink, flip, any of that before you move your graph up and down. Okay. So 0, 0, if I multiply by 1/2 stays there. Then I go left 2, down 3. 1, 1, if I multiply by 1/2 goes to 1, 1/2. Left 2, down 3. 4, 2, we go to 4, 1, left 2, down 3. So it looks like that. How are we doing, guys? Do you guys want some more examples? Let's do why don't you guys try this one before I move on? Our chair. What does the negative in front do? Left or flip over the x-axis. What's the -2 on the inside do? And the +1? Upward. You do need to make sure that you flip before you move up or down. Okay, up and down has to be the last thing. So if I take 0, 0 and reflect it, it doesn't go anywhere. Then right 2, up 1. If I take 1, 1 and reflect it, it goes to 1, negative 1. Then right 2, up 1. If you wanted, you could do 2, 8. It would go to 2, negative 8. Right 2 and up 1. Negative 1, negative 1. If you reflect it, it goes to negative 1, 1. Right 2 and up 1. If you wanted negative 2, negative 8, would go to negative 2, 8. Right 2, up 1. Our graph should look something like that. Are we doing okay with these? What I want to do then is skip down. I want to talk about symmetry. Okay, so I'm actually probably going to skip the next slide unless you guys really wanted me to do it. Just taking the transformation. So on this first one, what would it do to my graph? Moves it down 2. So you just take points on your graph and slide them all down 2. So are we okay with something like that? Okay. Symmetry. So you've had art before. You've probably talked about lines of symmetry. You know, a line you can fold something over so it's the same on both sides. Our graphs have symmetry. Symmetric to the y-axis. So think about if I gave you a graph like this. Okay, if I were a good artist, I'm going for roughly the same because I'm not perfect. But if I fold that over the y-axis, would that overlap? Yes. If I were better at drawing, it would be anyway. So it means symmetric to the y-axis if folding it on the y-axis gives the same thing on both sides. If you want to think about ordered pairwise, what that's saying, this is the point 2, 1, the other side negative 2, 1. If it's symmetric to the y, whether x is positive or negative, you're getting the same y value out. Symmetric to the x. So if I'm going to fold this over the x-axis, and it overlaps itself. So maybe okay. If you think about your ordered pairs, this is 2, 1, and 2, negative 1. Whether your y is positive or negative, the x is equal to the same thing. Symmetric to the origin would be something like this. We have a graph that has these points. So an origin requires 2 flips to get there. You have to flip it over the y and the x. If you think about your points, 1, 2, negative 1, negative 2. The x and y are both opposites. So if you're looking at the graph itself, you can decide, how is this symmetric? If I fold it over the y, does it overlap? If I fold it over the x, does it overlap? If we don't have the graph, then we have to think a little bit more about the equations. And so there's a couple different ways to do that. One of them is by plugging in negatives. So if I want to check if it's symmetric to the x-axis, okay, think about symmetry to the x-axis. Y and negative 1 have to give the same answer. If you think about your ordered pairs, when I put in 1 or negative 1, I got 2 both times. What we do to check symmetry to the x-axis is replace y with the opposite of y. What happens if you do the absolute value of a negative? Yeah. So that is the exact same thing as the absolute value of positive y, right? If you plug in the negative y and you get the same thing you started with, then yes, it is symmetric. So this graph is symmetric to the x-axis. If I want to check the y-axis, we replace x with a negative x. If I put in a negative x, is there anything I can do to turn this back into the original equation? No. So this one is not symmetric to the y-axis. If I want to check origin, we have to do both. We replace the x with a negative x, the y with a negative y. So you would have negative x equals the absolute value of negative y. Does that turn back into my original? No. You can get negative x equals the absolute value of y, but that's not what we started with. So this graph is symmetric to the x-axis only. You could have also graphed it if you wanted to get there. So if I want to check this one, to check the x-axis, what do? Make the y a negative. Does that turn back into the original one? No. Just have a negative there, there's no way to get rid of it, so that one is not. How do we check the y-axis? Oh my goodness. How do we check symmetry to the y-axis? Change x to negative. Okay, a negative cubed is still negative. Negative 2 times negative x is positive 2x. Is that what we started with? No. So that one is not symmetric to the y-axis. For origin, we do both. The y is negative and the x is negative. Negative y equals negative x cubed plus 2x. What could you do right now? Could I either multiply or divide by negative 1 on both sides? So we get y equals x cubed minus 2x. Is that what we started with? Yeah. Yes. So this graph is symmetric to the origin only. Any questions on those? Let's try a few more. Make sure we've got it. So C, how do you check the x-axis? Make your y negative. So minus negative y would make plus y. Is that what we started with? No. How do we check y-axis? Make your x negative. Is that what I started with? No. How do we check origin? Both the x and the y. So I get a negative 2x plus y equals 6. I can multiply by a negative on this one, but then it would be 2x minus y equals negative 6. So is that what I started with either? No. So this one has no symmetry. So we've seen a couple that have one type. We've seen one that doesn't have any. So symmetry does not always happen. If I look at the last one, to check the x-axis, you make your y negative. What happens if you square a negative? Ooh. Negative y times negative y is positive y squared. And that's what I started with. So is this one symmetric to the x? Okay, check the y. So you plug in a negative for the x. Negative x times negative x is positive x squared plus y squared equals 25. So that is yes. What about origin? Yeah. Square both of them, we get the same. So this one had all 3 types of symmetry. So you can have multiple types of symmetry, you can't have only one, or you have none at all. You guys know what this x squared plus y squared equals 25? What's that the graph of? A circle with the center at 0, 0. So that's why it has all the types of symmetry. All right, questions about the meaning of symmetry? Last thing in this section. So it goes along with symmetry. If something is symmetric to the x-axis, is it a function? If we think back, symmetric to the x, is this a function? No, it fails the vertical line test. So functions can only be symmetric to the y or the origin. They actually have special names for this. If it's a function symmetric to the y, they call that an even function. Symmetric to the origin is called odd. I always remember it by the O's to go together. Odd is origin. Okay, so even is the y-axis. So if we are being asked in terms of functions, you might just be told, tell me if this is even or odd. If I look at this one, even, odd, or neither? Even. This is symmetric to the y-axis. Think about if I flip this thing over the y-axis, it's the same on both sides, so that is even. Okay, is this one symmetric to the y? No. Odd is symmetric to the origin. That means you flip it over the y, and then you take that and flip it over the x. If you do two flips, does it overlap? Yes. So that one is odd. Okay, what about this one? If I flip over the y, it would look like this. And then if I flip over the x, it overlaps itself again. So that's odd. What about this one? Also odd. All right. In terms of evaluating it from the equation, you have two options. You could change this to y equals x squared minus 5 and do the same thing as we did for x-axis, y-axis, origin. You could also use your function notation to help. Even is symmetric to the y. We said if it's symmetric to the y, a positive and negative x give you the same thing. So you could plug in a negative, and if you get back your original function, it's even. Odd says both the x and the y flip signs. So if you plug in a negative x, you have to get the opposite of y. So what we could just do, it's a little bit faster, plug in negative x. If we get the original function, it's even. If we get the exact opposite, it's odd. And anything else is neither. So final slide of the day. If I want to check this, all we have to do is do f of negative x. If I plug in a negative, negative x times negative x is positive x squared. And that's what we started with. So that means my function is even. So if you plug in negative, you get the original back, that's even. B. If I plug in a negative, negative x times negative x times negative x is still a negative. Is that what we started with? No. Is it the exact opposite? The original times negative 1? No. So this one is neither. Last one, you put in a negative x. Okay, negative cubed is still negative. So this would give me a negative 5x cubed. Minus a negative is plus x. Is that what we started with? No. Is that the exact opposite? The original times negative 1? Yes. So if it's the opposite, that means odd. Opposite odd. Are there any questions? So yesterday I gave you a handout that is due tomorrow. So you have the rest of class to